Good morning everyone. So we are going to discuss about feedback amplifiers. Okay. In our last classes we are already discussed about what amplifiers. What is meant by amplifier and classification of amplifier, and based on coupling, RC couple as well as transformer couple is there. Okay. So in today's class we are going to discuss about feedback amplifiers as well as Darlington pair circuit. So before going to discuss about Darlington pair circuit, once we would like to revise previous class topics. First thing, what is meant by amplifier? So it is a circuit which is used to increase the strength of weak signal is called what? Amplifier. It is a device which is used to increase the strength of weak signal is called amplifier. And we are coming to the next thing, the property of increasing the strength of weak signal is called amplification. Okay, amplifier is a device which is used to increase the strength of weak signal. So amplification means it is the property of amplifier is used to increase the strength of weak signal. And classification of amplifier also over. In classification based on coupling, the amplifiers are classified into three types. One is called RC couple, other is called transformer couple, and the other one is called direct couple. Okay, in RC couple, resistor and capacitor is used as a coupling element. So here the coupling elements are used to connect the output of one stage to the input of next stage. If we are connecting the output of one stage to the next stage with help of resistor and capacitor, then the circuit is called RC coupled amplifier. And if we use transformers to connect the output of one stage to the next stage input, then the circuit is called transformer coupled amplifier. If no element is there between the input and output, then the circuit is called direct coupled amplifier. Okay, these three kinds of amplifiers are there based on coupling. And based on number of stages also the amplifiers are classified into two types. First one is called single stage amplifier and second one is called multi-stage amplifier. Okay, so based on coupling, the amplifiers are classified into two types, single stage amplifier as well as multi-stage amplifier. And while coming to the factor which is to be amplified, based on that amplifiers are classified into three types, means whether we are amplifying voltage or it may be current or it may be power. If we amplify the voltage signal, then the amplifiers are called voltage amplifiers, and if we amplify the current signal, then these are called current amplifier. If we amplify the power signal, then the amplifiers are called power amplifier. And while coming to the frequency also, means based on frequency, the amplifiers are classified into two types. One is called audio frequency, other is called radio frequency. If the amplifiers are used to amplify the signals having the frequency range in between 20 Hz to 20 kHz, then the amplifier is called audio frequency amplifier. If the above 20 kHz frequency signals are amplified by an amplifier, then that amplifier is called radio frequency amplifier. Is it okay? Next, one more classification is there. According to the configuration, the amplifiers are classified into three types: common base amplifier, common emitter amplifier, common collector amplifier. While coming to the common emitter amplifier, so here the emitter terminal is common in between the input and output, and it is connected to the ground. So then that configuration is called common emitter configuration. If base terminal is common between the input and output, then that configuration is called common base configuration. If collector terminal is common between the input and output, then that configuration is called common collector configuration. So finally, based on the configuration, amplifiers are classified into three types: common emitter, common base, common collector. Okay, and while coming to the next point that is discussed in our last class is multi-stage amplifier. What is meant by multi-stage amplifier? If we are connecting one stage amplifier to the next stage with help of coupling elements, then that amplifier is called multi-stage amplifier. the output of one stage is connected to the input of next stage, then that amplifier is called multi-stage amplifier. Okay, and what is the need of multi-stage amplifier? While coming to the need, to increase the strength of the weak signal with one amplifier is not enough to drive much more applications. Okay, means the output of single amplifier is not sufficient to drive the loads, so that there will be a need of connecting multiple amplifiers together. If the amplifiers are connected together, then that final amplifier is called multi-stage amplifier. If the amplifier's output of one stage is connected to the input of next stage, then that connection is called cascade connection. Connection is called cascade connection. So here one more thing is there. If common emitter amplifiers are used all stages, then that is called cascaded amplifier. One time common emitter is used and the second time common base is used, then that amplifier is called cascaded amplifier. Okay, all common emitter stages cascaded. One is common emitter, other are common base, then that is called cascaded. And while coming to the important parameters, those belongs to our multi-stage amplifier are gain, frequency response, and the last one is bandwidth. While coming to the gain of multi-stage amplifier, it is the product of all individual gains. Okay, simply the gain of multi-stage amplifier is came from, it is the product of gains of all individual stages. And while coming to the frequency response, the curve that must be drawn between the frequency and gain of the given voltage signal. The curve that must be drawn between the frequency and gain of the given signal, then that is called frequency response. And the next one is bandwidth. Okay, the range of the frequencies having constant amplitude where it attains the 70.7% of its maximum gain. Okay, the range of frequencies those attains 70.7% of its maximum gain, then that is called what? Bandwidth. Then that is called bandwidth. So these are the three important parameters of multi-stage amplifiers. In our last class we are also finished about single stage RC coupled amplifier. So in RC coupled amplifiers, what is the coupling elements? Resistor as well as capacitor. So see here the capacitor is used to connect the output of one stage to the input of next stage and so on. Okay. And while coming to the construction, in two-stage RC coupled amplifier, consisting of two transistors, okay, and one transistor combination consisting of two resistors for providing biasing and stabilization, and one capacitor Cin is used to allow only the AC input signal and to block the DC, and the emitter bypass resistor and the capacitor combination is also there, okay, to provide the low reactance path to the amplitude signal. Okay, so this is the construction of our two-stage RC coupled amplifier. So finally, in two-stage RC coupled amplifier, how many number of capacitors are there? 3 capacitors are there. One is called Cin, second one is called Cc, third one is called Cout. Here input capacitor is used to allow only the AC and block the DC signal. Output capacitor is used to connect pure output AC is to the load, and CC coupling capacitor is used to connect the output of first stage to the next stage. So this is construction. And while coming to the operation, when the circuit is switched on, the input voltage must be, weak signal must be amplified by the transistor C1, and the amplified version is appeared across the collector terminal of T1, and it must be connected to the base of T2 through the capacitor. So in this way the signal must be amplified, and finally we are getting the output at the collector of T2. So this is about what? Construction and operation of RC coupled amplifier. And while coming to the frequency response of amplifier, and see here it provides constant frequency where the gain attains 70.7% of its maximum value. And at low values the frequency must be false, and at high values also, means high frequency values also, the gain must be reduced. Why it happen means capacitive elements will provide the low reactance spark to the high and low frequency signal, so that there the gain must be reduced. It provide constant, okay, the frequency must be constant at 70.7% of its maximum gain. So below 70.7% of its gain and above 70% of gain, the frequency must be reduced. Okay, this is about what our frequency response of RC coupled amplifier. And see here, while coming to the next one, transformer coupled amplifier. Everything is same except the coupling element. Here we are using the transformer. Okay, here also it consisting of resistor biasing network R1 R2. It provide biasing and stabilization, and also REC for providing the low reactance path to the output signal. And only the difference is the transformer is placed across the coupling stage. Means whatever the output were appeared across the collector of transistor T1 is connected to the base of T2 with help of transformer. So that the primary winding is connected to the collector of T1 and secondary winding is connected to the base of T2. And see here, when the output voltage is appeared across the collector terminal, the primary winding accepts it and transfer it to the secondary winding according to the Faraday's laws of induction, Faraday's laws of electromagnetic induction. What is meant by Faraday's law? Whenever a conductor cut the magnetic flux, EMF will be induced. That EMF induced means that induced EMF is directly proportional to the rate of change of flux leakages. Okay, so according to this law, the primary winding will transfer the voltage to the secondary winding, and through it will be connected to the base of transistor T2. And because of we are using transformer here, high frequency signals also be amplified. In previous case only low frequency, but here high frequency also will be amplified. So this is about what? Transformer coupled amplifier. But here compared to the high RC coupled, the transformer coupled having 4 frequency response. That means frequency is not constant at all, it must be increased and increased, decreased, increased. And while coming to the last one, direct coupled amplifier is also there. In direct coupled amplifier, no coupling elements are used to connect the output of one stage to the input of next stage. Okay, no coupling element is used to connect the output of one stage to the input of next stage. So here advantage is what in the direct coupled amplifier, it is very suitable for low frequency amplification. Means it is used to amplify the signals having low frequency. But for high frequency it is not suitable. So this is about what our direct coupled amplifier. So these are the topics we are discussed in our last class. So now we are going to discuss about what? Darlington circuits. Okay. So Darlington pair is simply like a direct coupled amplifier. Here two transistors are connected together, then that is called what? Darlington pair circuit. And the two circuits also made with common emitter configuration. Two common emitter configuration circuits are connected together, then that is called what? Darlington pair. This Darlington pair is used to increase the gain of the signal. What is the use of Darlington pair? It is used to increase the gain of the circuit or given signal. And how it is made? By connecting two common emitter configuration circuits together, it will be produced by connecting two common emitter configurations. So once see the circuit here. So this is the transistor T1, this is the emitter terminal, and this is base, and this is collector terminal. And for the transistor T2, again it is emitter and it is base and it is collector. While observing the construction, so see here in our slide, two configurations are there. One is NPN, other one is PNP. Both are there. NPN is there, PNP Darlington pair is there. So see, while coming to the first one, NPN Darlington pair, so base emitter collectors are already identified. See here, the input will be given to the base of first transistor. Basic input will be given to the base of transistor T1. And next, the collectors of both the transistors are connected together. Okay, collectors of both transistors are connected together and given to the supply voltage. Okay, are connected together and given to the supply voltage. And while coming to the next thing, the emitter of transistor T1 is given to the base of T2. Emitter of T1 is connected to the base of T2, and the emitter of T2 is connected to ground. Okay, and see here, the main input is given to the base of transistor T1. The signal is to be amplified and produced across its emitter terminal, and the amplified signal is appeared across the emitter terminal is now connected to the base of transistor T2, and again the amplified version is appeared across emitter. Okay, and collector terminals are connected together and connected to the supply voltage, so that here from the supply voltage we are getting the current IC. It is divided into the two parts according to the KCL, Kirchhoff current law. Entering currents are is equal to the leaving current, so IC is equal to IC1 plus IC2. Okay, so this is about what? Construction of NPN Darlington pair. And while coming to the working, whatever the input voltage applied across base of T1 is amplified will be given to the base. Simply the output follows the input, and again it will be given to the emitter of T2. So in this way the gain must be increased. And see here, this is a PNP Darling configuration. Only the difference is here emitter terminal is indicated downside and here it is upside. And while coming to the operation, in NPN, majority carriers are electron. In PNP, majority carriers are holes. Means in NPN, the current conduction is due to the electrons, and in PNP, the current conduction is due to the holes. And while coming to the PNP Darlington pair, it consisting of 3 again 2 PNP transistors. The input voltage is applied across base terminal. Okay, see once. Okay, see here the input voltage is applied across base terminal, and whatever the voltage we are getting, that is again passed to the collector. And see here, collectors of both transistor T1 and T2 are connected together. Okay, the voltage must be applied across here, must be given to our transistor T2. The amplified version is produced across base, and then the output of T2 is connected to the T1 inputs, and finally we getting the output across the base of T1. In this configuration, here we are applying the input across the base of T1. Here we are getting outputs across the base of T1. Here we are common collector terminals are connected together to give the supply voltage, but output voltage is applied across emitter. Here base. Here input is applied base. Here the input is applied across the emitter. So this is about what? Construction and operation of Darlington pair circuits. So already I explained the two transistors are connected in series like this. NPN PNP transistor configuration is over. See here, while coming to this slide, here they explain in Darlington the transistor acts like a single transistor that has high current gain and high impedance. Why? Because here the two transistors are connected in series. Darlington transistor acts like a single transistor that has high current gain and high input impedance. Why it acts like a single circuit means both emitters are connected together, both bases collectors are connected together. Okay, input is applied across base, and it is again also in second input is applied in the base, so that the Darlington circuit acts like a single transistor but has high current gain and high input impedance. And see here, the Darlington pair is also available in NPN and PNP. The emitter of first transistor is connected to the base of transistor, and collector terminals of two transistors are connected together. Already I explained all these things. Okay. And see here, while coming to the current gain, for mathematical expression of current gain for Darlington pair circuit is, here the product of the individual gains is equal to the whole current, whole gain. For example, see here, once I would like to draw the diagram here. For example, this is our Darlington pair base and both okay, connector, emitter, and also emitter. This is base. Okay, so now this is the Darlington wave. The gain of whole is equal to the gain of individual stages, product of individual. Beta is equal to beta 1 into beta 2, means the whole gain. The gain of Darlington phase circuit is equal to the products of gains of individual stages. Transistor T1 having beta 1, transistor T2 having beta 2. So the gain is equal to the product of the individual stage gains. Is it clear? And see here, a clear picture is there. It is with the combination of additional resistors and capacitors. Except resistors and capacitor, it's simple, our Darlington pair symbol. See here, this is the transistor. Here it is indicated with Q1, and second transistor is indicated with Q2. Okay, and whatever the input voltage, that must be applied to the transistor Q1. Okay, this is the input voltage. It is applied to the base of Q1 through the coupling capacitor C. Okay, how can we apply the input voltage to the base of the transistor Q1? It is applied through the capacitor C. Why here we using capacitor to connect the input to the base of the transistor? Capacitors allow only the AC signal. It will block the DC signal. So cause of it will only allow the AC and blocking DC signal. Unwanted disturbance signals must be eliminated so that noise will be reduced. Okay. So next, while coming to the output, we are getting the output across the emitter of Q1. Okay. The given signal is connected to the base of transistor Q1, and it will produce the output across the emitter. So through this emitter, because of it is connected to the base of Q2, the output of Q1 is connected to the base of Q2. Okay, output of Q1 is connected to the input of Q2, means output is produced across emitter terminal of Q1 is connected to the input that is connected to Q2 with the base. Okay, so emitter and base are connected together. And next thing, here the emitter terminal of Q2 is connected to ground through RE. Emitter terminal is connected to ground through RE. And most important thing already we discussed is collector terminals are connected together and given to supply voltage VCC. According to the voltage current KCL, Kirchhoff current law, current is divided into two parts, IC1 and IC2. The current reached at a point is equal to the means entering currents are is equal to the leaving currents. Okay, and here compared to previous one, two resistors are used, looking like how it is potential divider bias network. So what is the use of resistors R1 and R2? If they act like a potential divider bias, providing a resistor biasing and stabilization network. So what is the need of biasing circuit? It makes the operating point independent of temperature variations. So if it makes the operating point independent of the temperature variations, then what is the advantage to us? provide constant gain. If the operating point is independent on temperature, automatically the leakage currents will be increased. Due to that, the current gain increased again and again. Finally, the self-destruction of the transistors occurred. So the self-destruction, due to the self-destruction, okay, the transistors must be damaged. That problem is called thermal runaway. So to avoid thermal runaway and provide proper biasing and stabilization, the potential divider network is connected to the Darlington pair at input side, that is made with R1 and R2. So biasing means making the operating point independent of temperature variations. Okay, if it independence on temperature variations, so no thermal runaway will occur. And it also will provide stabilization, means the output is constant irrespective of the variations in the inputs. Is it clear? So this is the main theme of using potential divider network in the Darlington pair. So next, the input is applied across the base of transistor Q1 is to be amplified or produce the output across emitter of Q1, and this output is connected to the base of Q2. Again it will do the function and provide the final output across the emitter through the capacitor only. Always the capacitors are used to allow the AC only, and it will block the DC voltage. Okay, finally we will apply the input at the base of Q1 and the output at the base of Q2. So here the gain of first stage is indicated with beta 1. In first stage, what is the gain? So in first stage, beta 1 is the gain of first stage. So beta 1 is defined as the ratio of output by input. Output is indicated with IE1 and second one is IB1. And here beta 2 is defined as the current gain of second stage. So that is beta 2 is equal to first one output IE2 by IB2. So finally the whole gain is the product of the individual stages. So beta is equal to beta 1 into beta 2. Is it clear? So finally the gain of Darlington pair is defined as the gain is equal to the gain product of the gains of the individual stages. So beta is equal to beta 1 into beta 2. Okay, this is about what? Darlington pair circuit. Already. If beta 1 is equal to beta 2, okay, if beta 1 and beta 2 are different, that is not the case. If beta 1 is equal to beta 2, what we are getting here, say IC is equal to beta 1 plus beta 2 into beta 1 plus beta 2 into IB, and IC is equal to what? Beta square plus 2B into IB. Okay, if beta 1 is equal to beta 2, we are getting like this. And see here why we designing the Darlington pair. What is the need of designing of Darlington pair means it having high input impedance, and also high current gain. The main theme of designing Darlington pair circuit also high current gain and high input impedance. And see, it will provide the low output impedance. Okay, high input impedance is high but low output impedance, and it uses very few components. That is also main advantage. Cause of using few components, circuit becomes simple, and also it is inexpensive. Inexpensive means paying low cost, that is called economical, and it is well for impedance matching circuit. Okay, so to whom it is well? It is well for impedance matching circuits. And the major drawback of the Darlington circuit transistor pair is that the leakage current of the first transistor is amplified by the second current. So see here, what is the main drawback? The leakage currents also amplified. Okay, the leakage currents of the first transistor is also amplified by the second. Of course, here transistor biasing is there, but it is connected only across first stage. But it is not at second stage now. So that leakage currents of first is amplified across the second stage. So this is the disadvantage of the Darlington pair circuit. And while coming to the next point, if the overall leakage current becomes high, maybe there will be a chance of getting thermal runaway so that it not works properly. And while coming to the applications of Darlington pair, applications means where we are using the Darlington pair circuit. So see here the Darlington pair connections are used in first one voltage regulators. Why? Because it will provide high voltage gain, so that the circuits are used in voltage gains, voltage regulators, and these are also used in power amplifiers and used in high gain operational amplifiers and high current switching applications. Okay, the Darlington pair also used in voltage regulators and power amplifiers, and these are also used in high gain operational amplifiers, high current switching applications. So this is about what Darlington pair, applications of Darlington pair. And see here, this is the only simple symbol of Darlington pair. Emitter is connected to base, input is connected to base through the load resistor or capacitor, and again the output is applied from the emitter. Here emitter and base are connected together. Okay, and collector is connected to the load. Both collectors are connected together load. And see here, this is the high current gain Darlington amplifier. What it is? High current gain amplifier. Both are same. A little bit difference is there. So see here a high current gain Darlington pair is also made with two transistors with the same package. That is only the different. Same package, if it is Intel or whatever it may be. Here we are using the same package, identical transistors are required. So if we are designing the Darlington pair with same identical transistors, then that is called, means that is used for high current gain Darlington amplifier. The amount of current is passed to the load line in the circuit above when the transistor is turned on. Means if when the apply voltage is switched on, the load current is equal to what? Input current into transistor gain. Okay, how can we express the load current? The load current is equal to input current into transistor gain. And see here, the current gain varies for different transistors. Okay, current gain means if the transistors having identical parameters, na, but the next time if we are using other transistors, they are made from other different factory, the current gain also will be changed. Okay, and see here we are facing one question in examination. What is the need of Darlington pair? Why we are moving with Darlington pair? So in the applications of transistors, that will provide the low current gain. If we connecting one stage output to the next stage, finally we are getting the high output gain, so that we are working with our Darlington pair. So see here, the total current gain is equal to current gain of transistor 1 and 2. For example, if two transistors having current gain 100, by using these two transistors, finally we are getting what? 10,000. Okay, so that means it is very very high compared to the transistors using individually. For example, if we are working with transistor T1 individually, we are getting gain only 100. Is it clear? If we are working with transistor T1, we are getting gain 100 only, and while working with T2 also we are getting gain 100, but while adding these two, we are getting product of individual stages, that is 10,000, so that it is increased very very high. That means very vastly increased. Vastly means very high level increment is there compared to the single transistor, so that Darlington pair is used. Okay, what is meant by Darlington pair? Two transistors are connected together to increase the high current gain. Why? Because here the product of the individual gains is equal to the product of whole. So in this way, the current gain must be increased very very high, so that instead of using single stages, we are using combinational amplifier, that is called Darlington pair. Okay, 10 times the gain must be increased, so that we are preferring the Darlington amplifier. Okay, and see here, next one is called what? Cascade amplifier. Okay, already I told you, if common emitter amplifiers are connected together in two-stage RC coupled amplifier, then that is called what? Cascade amplifier. See here also it is there two transistors, which means two common emitter. Here it is Q1 is there, Q2 is there. It is also common emitter. Here it is emitter terminal, this is base, this is collector. So emitter is common between both base and collector. Input is applied across base and output is collected from collector with respect to of emitter, and it is connected to ground, so that it is common emitter. And while coming to the next one, here also the emitter is connected to ground, and base we are getting the output from previous stage output. At collector we are collecting the output. Here also emitter is common. So here we are using two common emitter stages are connected together to produce the outputs. Then that connection or the name of the amplifier is called what? Cascade amplifier. Okay. See here also the two common emitter amplifiers are there, but two are, one is NPN, other one is PNP. One is NPN, other one is PNP. And here resistor divided network, potential divider network is there. So that is used to provide the biasing and stabilization network. Okay. If the two-stage amplifiers in which common emitter stage is connected to the next stage, common base. Okay. Previous one cascaded, it is cascoded. So in cascoded stage, common one is common emitter, other one is common base. If the transistor connection like this, then that is called what? Cascode amplifier. And see here the three resistors R1, R2, R3 are used for biasing transistors Q1 and Q3. Already I explained you many times. Biasing means what? Provide emitter base is in forward bias condition and collector base is in reverse bias condition. Then the transistors are operates in active region. So what is the use of operating transistors in active region? While operating the transistors in active region, the operating point makes independent of temperature variations, so that it will provide constant gain. Otherwise, it must be varied with the temperature variations. If it varied with the temperature variations, thermal runaway will be occurred. So to avoid the thermal runaway, to protect it from the thermal runaway, we are using R1, R2, R3. Okay. And already explained, output is appeared across the collector. So see here in the working, input signal is applied across the base. Already I told you, which amplifies it with unity gain, and the output voltage is applied across the collector one. Okay, input is applied across base of Q1. The output of Q1 is appeared across the collector of Q1, and it acts as a mixture. The output of collector is connected to the base of Q2, and again the amplified version is appeared across the collector of Q2. Okay, and what is the need of this? To perform the small signal analysis. Okay, to perform the small signal analysis, here we need to draw the equivalent circuits, and here in the circuit all capacitors must be replaced by the short circuits. Okay, cause of by using capacitors it will provide low reactance path, so that here we are eliminating or avoiding the capacitor circuit. Okay, so in our last class what we have discussed, so today's topics are what? Darlington pair, cascade amplifier, cascode amplifier, and what is the need of Darlington amplifier. So what is the need of Darlington amplifier? So Darlington pair amplifiers are used, okay, Darlington amplifiers are used to increase the gain. Okay, how many number of transistors are there in Darlington pair circuit? 2 transistors are there in our Darlington pair circuits. And what is the need? To increase the gain. We are working with our Darlington pair. So in simply, Darlington pair means what? RC coupled amplifiers of common emitter are connected together. That is called what? Darlington pair. And so before going to conclusion, we have discussed about the previous question, means frequently asked questions. While coming to the 5 marks, they are asking about Write the expression for current gain of Darlington pair. Okay, means you draw the diagram and write the equations. That is enough. Okay, derive the expression for current gain of Darlington pair. And more one 5 marks question is there. Explain the construction and working of Darlington pair. What is the first question? Explain the working and operation of Darlington pair. And why we prefer the Darlington pair? Okay, you explain our construction and operation. Why we are preferring Darlington pair? So to increase the gain, we are preferring the Darlington pair. Okay. And while coming to the 1 mark questions, state the Darlington pair. If two common emitter transistors are connected together, then that is called what? Darlington pair. And while coming to the multiple choice questions, we may face it in our all competitive examinations. The questions are like the Darlington pairs are used to increase the gain, or to increase the input impedance, or to increase the output impedance. None of the above. What is our answer? To increase the gain. Sometimes they also ask like Darlington pairs are used to increase the gain, or to decrease the gain, or increase the input impedance, decrease the input impedance. What is our answer? Only our choice is increase the gain. And while coming to the next one, in cascade amplifier, two common emitters are used, two common bases are used, two common collectors are used, or none of the above. So what is our answer? Two common emitters are used in cascade connection. Okay. And while coming to the next one, in cascade amplifier, common emitter, common base is used, common base, common collector is used, common collector, common emitter is used, none of the above. Okay. What is our answer now? Common emitter and common base is used. Okay. And in both cascade configuration or maybe Darlington pair, what is the purpose of resistors R1 and R2? In the absence of resistors R1 and R2, what happened? So here the resistors R1 and R2 is used for providing proper biasing. What is meant by biasing? Make emitter base is in forward bias condition and collector base is in reverse bias condition. Okay, so that the transistor operates in active region. Okay, that means here the operating point is independent of temperature variations, so that output becomes stable irrespective of the temperature variations. Is it clear? So this is about what need of resistors R1 and R2. What is the need of resistors R1 and R2? It provides the biasing and stabilization. What is the need of biasing? To make operating point independent of temperature variations and transistor parameters. If the R1 is R2 is not there, the leakage currents must be increased due to the temperature variations. If once the leakage currents are increased, automatically the Darlington pair circuit will provide low gain due to the disturbances will be produced. Okay, so this is the use of resistors R1 and R2. And what is the need of input capacitor, or why we are connecting one capacitor across the inputs? Okay, so here need of input capacitor is used to allow only the AC signal and it will block the DC signal. Is it clear? So this is about what our Darlington pair circuit. And while coming to the cascade and cascode, in both cascade and cascode configurations, okay, cascade is simply like our two transistor stage, and cascode is also two stage RC coupled amplifier. But in cascade connection, the two common emitters are connected together, and in common base and common emitter of NPN type and PNP. So while coming to the 1 mark questions, state the need of Darlington pair, and state what is meant by cascade amplifier or stage cascode amplifier. So these are the 1 mark question. And while coming to the 3 mark questions, they ask you about advantages of Darlington pair and disadvantages of Darlington pair, advantages of cascade configuration and disadvantages of cascade, configuration, these are under comes into the 3 marks questions. And also applications also under comes into the 3 marks. So mostly advantages, applications are under fall into the 3 marks questions. Statements, needs are under comes into the 1 mark question. Construction, working principle are under comes into the, and also mathematical expressions are under comes into the 5 marks questions. Okay. So now I would like to conclude the class. Meet you in tomorrow's session.